Okay, good morning. Today we were supposed to have the exercise session, but I don't think we have covered so much. So I would write some problems for you, and then we solve that. That is on the topic of divisibility, and that would be the last session we will talk about this. So we will move forward from now, next session. Okay, so let me just start writing some problems here for you to see how it works. So example. Let A and B, I underline them so that I mean these are mathematical variables. Let A and B be non-zero integers such that we know 13 divides A plus 3B. Show that 13 also divides 9A plus B. Okay, so what do I mean by this question? I mean that I don't know anything about A and B. What I know is that they are non-zero and they satisfy this condition. I want to show that as soon as they satisfy this condition, they have to also satisfy the other condition there, yes? So for example, let us, by the way, can you find a pair of numbers that satisfies this? I just want to confirm that this is true. For example, if you can come up with some example for A and B so that this works, I put those numbers that you gave me here to see that if it also works. Yes, Gustav?
A is 10 and B is 1.
Okay, A is 10, B is 1. That is correct, because 10 plus 3 is 13. A is 10, I put it here, 90. B is 1, so it becomes 91, and 91 is divisible by 13, so that's correct. So this tells you that not only 10 and 1, but any pair that you can find that works here will also work there. Yes? So we want to prove it in general, not just because of, not only for this pair of numbers. So how can we prove that? Do you have any idea? So you have to be creative. I know that because even if I slightly change the numbers, I myself might get into trouble. That's the nature of discrete mathematics, so you need to get used to this, okay? So at least let us start. This is my assumption. So what can I write? You are telling me that 13 divides A plus 3B. Then this means that everyone should be able to write this down, yes? There exists a Q where in the set of integers with which property, so that the right hand side of this relation A plus 3B is the number on the left, which is in this case 13 times that integer Q. Yes? Of course I am saying that there problem to problem it changes, yes, but you need to have some strategy to tackle. This is a very good place to teach you that if you want to solve a math problem without any strategy, it is more or less useless. If you are very, very extremely lucky, then you will find the answer by just random calculations. But this is so rare that probably you shouldn't count on that. So this is what I have in my hand. Then I want to say something about this combination 9A plus B. So then you need to ask yourself and remind yourself about your math knowledge so that be able to go from here to there. So you see that this relation is related to this combination, A plus 3B. But what do I need? I need this combination. Okay, now I want to hear from you. So what do you think I should do? Because apparently, okay, so I want you, because I want you to tell me your guesses so that we start working on it. If it is working, very good. If not, we see why. I mean, this is the only way to learn these if you want to solve problems independent of your teacher? Do you have any idea? It can, so you have to have some idea. Yes, assume that my gun is in your head now. So if you don't have any idea, I will shoot. Then probably you will say something, yes? Yes, Rocco?
Maybe we could try writing out the same thing if we 13 divides 9a plus b.
No, that is not a good idea. Okay, that is good in a scratch work. So you go in a scratch work, and you don't need to be very precise. So what you see is 9a plus b is 13 sine q prime. So that's it. Okay. But then what?
You just said we had to
Yes, yes. Yeah, it's better than dying. Yes, I know. But yes.
what if we add 8 to that and
This is reasonable. Yeah, it is a reasonable thing. First of all, try to understand that I want to go from this combination to say something about this combination. You see that the differences. Here the coefficient is 9, here the coefficient is 1, here the coefficient is 1, here the coefficient is 3. At least you can think in this way. Is there any way, a valid mathematical way to change a to 9a? I think the most natural one is what actually Robert mentioned. So I want to make a to be 9a. So what happens to my work? So I have to do trial and error, okay? So I will do 8a plus 3b. But you know that if I want to keep the equality, when I add 8a to the left, I have to add 8a to the right. Yes? So no one can criticize this, because if this is true, this is 100% true. And then more or less it is a little bit reasonable guess to do what? So it becomes 9a. And then I have plus 3b. And on the right hand side I have 13q plus 8a. Okay, so then what? But unfortunately still there are 3 b's left. What I need is just one single b, yes? So probably it's also natural to do that. So let us just do it in our head. So 9a plus, I subtract 2b from both sides, so it becomes b. On the right hand side I have to do the same thing, of course. 2b. If you tell me this is true, 100% this is also true. But there is one flaw to this, and that is it is useless. Yes? Yeah, but this is very good way of thinking. The first thing that comes to mind are the natural steps. This is, you should have a reason to go and find a better solution. So this is the way that I did it myself, probably when I was doing it for the first time. So because this is the most natural. Why this is useless? Because you succeeded to make this combination on the left, but if you want to be able to conclude this, you need to have a multiple of 13 on the right. But you don't have any multiple of 13. You might say that, okay, I factor 13 out. I agree with you. This becomes q. This becomes 8a over 13. This becomes minus 2b over 13. And can I delude myself into solving it by calling it capital Q and say that, okay, this is a multiple of 13, so 13 divides 9a plus b. Is this a valid argument? Up to here, everything is valid. But is the conclusion also correct? Why is that? Why? Yes? Exactly. There is no guarantee, because this is integer, good, but these are fractions, and there is no guarantee that this fraction at the end turns out to be an integer. So up to here, 100% correct. Unfortunately, the last step can be not taken. Okay, so this is not working. Okay, so unfortunately, it's a little bit painful, but this is the truth. Yes, we have to cross it over. Okay, I want to hear from you again. Okay. Might be it's better for me to shoot, yes. Yeah, but anyway, another idea. The idea is a little bit strange. Okay, can you see, for example, okay, this addition and subtraction was the most natural way. Unfortunately, it didn't work. Do you have any other idea? You should have at least one more idea. Yes? Yes? Okay, let me test your idea. What is your saying? So you say that, okay, a plus 3b is equal to 13q. What is the next step you're suggesting? Okay, I add 26a to both sides. It becomes what? So he is adding 26 a's. Yes? So then becomes what? 27 a's. Yes? And then this becomes 3b. On the right hand side, I have this. Yes? Okay, can you continue then? Here, should I take a 3 out? Yes. Yes. Yeah. What should I write for the right hand side? The same thing? Do you want me to write the same thing? Okay, so 13q. Yes. So I factor a 13 out. Yes. And then? Yeah. But this is correct. But it needs a little bit more advanced theorem, which is called Euclid lemma. But we haven't studied that yet. Okay, so this, what you can conclude is this. 13, this is an integer now. There is no fractions involved. Integer, integer, the addition is an integer. So 13 times an integer is this number. So what does it mean? It means 13 divides the left-hand side. Yes? And the reason there is that is the lemma, that there is no common factor between these two, so it has to divide the second one. But we haven't studied that one, so I don't want to use it. Okay, so that was actually a very good step. So I mean that this combination was a little bit strange, but it is actually working. Yes, but you need a little bit more advanced theorem because we haven't talked about that. So let us not, if you write this in the exam up to here, you will get some points, of course. Yes. By the way, these questions will not be in the exam. Okay. Yeah, these questions are, so the questions are above exactly the level of the book. But I want you to understand this is not beyond your ability. This is the whole goal of math courses, to improve your analytic skills to be able to solve harder problems. Okay, so any other way? So if you don't mind, it's correct, but it is a little bit more advanced. But any other way, another natural way, I want to go from here to this combination. Addition, this simple possible addition didn't work. This is strange way addition works, but it needs some more advanced theorem, so let us forego it. And then I need another thing. Tell me. Yes? Yes. That's another natural step. So what you do, so I have a plus 3b is equal to 13q. No, no worries. That's, we have to, by the way, don't think I was able to solve the problems. Most of the time, this is the way that I do, and I get tired and I sleep. I cannot solve the problem. Yes? Just let me, I mean that this is the natural way. Don't think that everything should be straightforward. In mathematics, usually nothing is straightforward. And if everything is straightforward, it is really boring. Yes? So what's the goal of doing what is everything is straightforward? No. So you multiply it by 9, as you said, but at least this is natural. Then unfortunately, this becomes what? 27, but don't worry. I multiply this by 9, and this is lazy to multiply. If you don't mind, let me write it like this. Yes, very good. Mhm. Yeah, what is the motive behind that? Because I need 1b. So that's more or less what actually Robert started, but he started with addition and subtraction. You started with multiplication and subtraction. Okay, so then you subtract 26b from both sides, so it becomes b. So I'm subtracting 26b. On the right hand side, I have 13 multiplied by 9, whatever this is not important for the time being, times q, and then I have minus 26b. Now it works. Yes? So because on the right hand side, on the left hand side, I have this combination. On the right hand side, I can have a factor of 13. Yes? So I can pull it out. Without, so then 13 is out, 9q is left, and then minus 2b is left. But can I guarantee that this is an integer? Yes, because q is an integer, b is an integer, so that combination is definitely an integer. Yes? So what I see this number is an integer multiple of 13. How complicated multiple is, I don't care. What I care is that that is just an integer. So what happens, I can immediately conclude that 13 divides 9a plus b, and then it worked. Okay, so we were able actually to solve that problem. Understandable? But at least there is no guarantee if I change the numbers a little bit. But at least you need, by the way, if you are interested in to be a good problem solver, you have to have a little bit of a strong memory. So you see that the natural way didn't work. So somehow you need to send this technique into your toolbox. You should have a toolbox. It's a big one. Whenever you learn something, this is a trick. You multiply it. Yes, it was not very natural, but it worked. Yes? Is that clear? Okay, but this is not the end of the story, because might be everything you know, but still you cannot solve the problem. Let me just give you another example, and then I want to wait so that you can come up with the answer. Very similar to this. So again, let me make it simple to write. Example. A and B, non-zero integers. Yes? And then I tell you that 17 divides 3a plus 4b plus 2, and then I am asking you to prove that 17 also divides this combination. Yes? Okay, this is the way that it is. You need to do a lot of trial and errors in the beginning at least. So I will pause recording and then wait for you to solve it. Any progress? No? It's tricky, I told you. Sometimes it doesn't work. But I can give you a guide, and I would say that if you learned what I said, you should be able to solve it. Okay? So again, the trick is multiplying. But multiplying by which number? Anyone? Any ideas? There is no way to come up with it except experience and a little bit of good luck. That number is 8. Yes? So you need to multiply by 8. There is no why. You will see. If this is the hard one. But what I expect is that after that, everyone that understood the previous problem should now be able to solve the new problem after the hint. Yes? There is no way to figure out. Yeah, and a little bit of experience and good luck, I told you. Because if you change the numbers a little bit, I was a little bit anxious myself. I was trying the numbers because I didn't remember how did I solve it before. So, but this is how it is. But after giving you this hint, if you have a complete understanding of what I said before, your chance to solve the problem would be above 99%. That's okay, did it work? No, so good. So if you could, I mean, but of course the problem is that how can I come up with that idea of multiplying by 8? Yes, I think it will come by experience, yes. So if you say that this is true, let me just solve it because I want to solve a little bit of diverse problems. So I would say that there exists a Q in Z such that 3a plus 4b plus 2 is 17 times Q, yes? I gave you the hint, so just follow the hint. I just ask you to multiply by 8. It is a little bit unreasonable because how multiplying by 8 will help me at the end to get that combination. Yes, but it will work. Yes, if I multiply by 8, what happens here? It becomes 24a plus 32b plus 16. I also multiply by 8. By the experience of the previous problem, you even don't bother to multiply them really. You just write 7 times the 8 times Q. If you want, of course, you can multiply it, but you don't need to. But after that, I told you that if you understand what the problem is, you should be able to solve it. You tell yourself that I need 7a, but how many a's do I have? I have 24a. I want to go back and make it 7a. So how should I do that? I subtract 17a. And as far as that is 17, you should be happy because 17 doesn't have any problem. I can factor it out. So I subtract 17a. So this becomes 7a. Let me write it like this. 17 times 8 times q minus 17a. So far, so good. But I need minus 2b, and that is unfortunate here. How much do I have? I have 32b. So I have to make it minus 2b. What I'm supposed to do? Yeah? 34. So I negative 34b. So then it becomes minus 2b. On the other side, negative 34b. But 34 is also nice because it is 2 times 17. Yes? And then 16, I don't like it. I want to have minus 1. So I have to subtract minus 17. So then it becomes minus 1 and then minus 17. Yes? And then this works because 17, 17, 17, 17, I can factor a 17 out. This becomes 8q. This becomes minus a. This becomes minus 2b. This becomes minus 1. But the good point is that I don't care how complicated it is. I just care if it is an integer or not, which in this case is guaranteed to be an integer. So this means that this number that you see is an integer multiple of 17. So therefore 17 also divides this number. Yes? Yep. Yeah, if you want to have 17 here, you should have a factor of 17 there. So that's the goal. Yes? Okay, now let me make a problem a little bit harder. I don't know if you have some experience. So again, example, a and b are non-zero integers. And then we know that 7 divides a minus 3b. I am asking you to show me, this is different from this question. 49 divides a little bit harder combination, 2a squared plus 37ab minus 31b squared. Yes? Yeah. I again pause the recording because this is important to come up with all ideas. You need to spend a long time, otherwise you will not learn. Yes. Okay, what kind of ideas do you have? Okay, let me write the first one. I think everyone agrees with this part at least, so I don't need to. So from here, I can conclude that there exists a Q in Z so that A minus 3B is 7 times Q. Okay, who raised the hand? Yes, Hadia? Okay, how many of you thought about squaring both sides? That's very good. Because, first of all, you need 49. That's a hint. But there is also one way to get 49. You can multiply by 7. Why did you choose to square rather than multiply? Because if you just multiply, you don't get a quadratic term here. But you see, you have some squares here as well. So at least this is reasonable to square rather than multiply by 7. Yes? So I square both sides as you told. So this means that A minus 3B to the power of 2 is 7Q totally squared. This becomes A squared. The first one squared 2 times the first one times the second one. And the second one squared. Yes? On the right hand side I will have 49Q squared. It is good. First of all, I have a combination here which is more similar to this than this. And then I have my 49. It's a good strategy. Yes? Okay, did you complete that or not? Okay, and then? By 2. Okay, so let us follow yours. What was the motive behind that? So you concentrated on one of these terms, and then you see that you have 2a squared, so it is not hard to guess to multiply by 2. Yes? So you multiply by 2, so this becomes this. But by the experience you learned so far, you really don't need to bother about multiplying this number really by 2. You can just juxtapose it there. Okay? Yeah, it works, yes. Because you say that, okay, 2a squared is good, but I don't like this. I like to have 37ab. Is there any way to compensate that? Yes. What is that? How much I should add? 49ab. That's good. Whenever 49 appears, I'm happy, yes? So this is 2a squared. Yes. By the way, that's a very good reward that you become happy so easily. Yes? When you add something and you become happy, it's a very good reward in life. Yes? How much you want to pay to be happy? Yes? But you're already happy. Yes? So you add what? 49ab. Then let us do it in our head. I add 49ab. So let me just write it for future if you want to read. And then it becomes 37ab. But I have to remember that 49 times 2 times q squared is there. I add 49ab. Yes? Okay, and then I have 18b squared. I want to have minus 31b squared. So what should I do? Negative 49 b squared, again happy. Yes? In 2 seconds, you become happy 2 times. So this becomes minus 31b squared. And then you have minus 49b squared here. Yes? And the problem is solved. Because then I can factor a 49 out. Is 2q squared here plus ab minus b squared. What I care is that this combination should be what? An integer. And it is. So end of the story. So you see that, I mean, this problem was completely different from the previous problem. But it is not that disappointing that every problem is something completely new. You cannot do anything. Yes, you could. That is the way, but I mean, if I change the numbers a little bit, it might be even hard for me, but at least I will try. I know how to try, okay? Well, that's the way that you also need to try. Yes? So this is so in discrete mathematics, you cannot say if this is happening, this one, what I should do. You should start all over again. Yeah. So that is the nature of this one. By the way, let me also share something with you to see. Whenever you want to do something new, this is the only way. You have to sit down and think. It doesn't matter if you're doing something, if you want to do a new project, I don't know, build a new bridge or building with some very peculiar property that no one has already done. You have to sit down and think. And of course, you should also learn a good way of collaborating. So it's very good if you have some teamwork to work on problems. It makes it more fun. So I give you 5 minutes. I just want you to see, do something, okay? You can do a lot of things. X and Y are natural, so it means, yes, they can be, yes. But in this case, that's a good question. Can you answer that? Can, in this particular case, X and Y be the same numbers? Yes or no? The answering this question is simple, yes, because if you say that X and Y are equal, then the left-hand side becomes 2 over X. Do you agree? And then on the right-hand side, you have 1 over 5. So then it means 10 is X. And Y is also 10, so that is working. So actually we found a pair. 10 and 10. Yes? You can choose 10 for X, you can choose 10 for Y, and that is working. So actually that was a good, better than nothing, yes? We found a pair. Yes? But is this, do you think this is the only pair, or we can find other pairs? I don't know. We have to think about it. And I want you to give me a method that everyone is convinced at the end, that these are the only ones, or there are no more. So you know that this is a question in number theory, because I am teaching you that part, so the examples probably are relevant. If you have this in mind, what would be your first step to solve the problem? Yes? Yeah, so that's one way. But no, I mean in general. Because I told you that number theory is a branch of mathematics discovering the properties of mainly. Yeah, you need to know the definition of number theory. So I told you that number theory is a branch of mathematics which is the goal is to understand the properties of integers. Yes? And then you see that I have fractions involved. Yes? So this means that probably if you want to use the tools in number theory to solve the problem, it is better to get rid of fractions. Yes? So that is the most natural way for me. Yes, because I want to get rid of fractions to be able to use the tools of number theory. Okay? So, but this is, if you understand this, then it should be a matter of 2 or 3 seconds for you to get rid of the fractions. How do you do that? 5 seconds passed. Yes? Yes? Common denominator, or more efficiently, common denominator is when you are doing math 1C. Now you are doing math 5. So what do you do? Still the same? That is correct. What you said, common denominator and the product of means is equal to the product of extremes or something. But it is better to multiply by 5x and y simultaneously. Yes? So you multiply by that. So can you do it in your head for me? So I have 5, I have x, I have y. I multiply everything by 5x and y. So what happens? What do I get here? 5y. What do I get here? 5x. What do I get here? xy. It is faster. Yes. So this is the so that we now have some equation without any fractions involved, and now this is pointing me. By the way, I am teaching you number theory, but assume that 2 years from now this question is given to you. As soon as you see that they are talking about natural numbers, you should remember the course of number analysis, number theories, because this is some equation with natural numbers involved. So you should have this in mind, that it might be related to number theory. Yes. So this one and that one are equivalent. So instead of thinking about this, which in number theory is hard, we can think about this. Yes? And try to find all possible values for x and y. Any idea how to do that?
So you could try and make this into the a plus b equals something times q structure.
Okay.
So you can move 5y, for example.
To the other side.
Yes.
So let us just follow you. So you say 5x is equal to xy, and then minus 5y. Then what?
Then you factor out 2y.
Okay. Good things, because these are, by the way, very natural things. So it means that you are following what I'm saying. Okay. Then?
That's all I've done. So
Yes, no, that's very good. But I see you, you understand yourself, this is not efficient. But your idea is correct. So you have the correct idea to factorize things, but it was not efficient, because how can I guess which one is which now? Okay, but something is clear. So if I ask you x and y are natural numbers, let me change my letters. So I give you a and b are natural numbers. And then I tell you the product of a and b is, I don't know, equal to 7. Then it is not hard to find all a's and b's. Because you ask yourself, I want to write 7 as a product of two numbers. How can you write it in general in integers? You can say 1 and 7. You can say minus 1 and minus 7. So one answer is that a is 1, b is 7. One answer is a is minus 1, b is minus 7. One answer is a is 7, b is 1, and etc. etc. Yes? Even if this number is not prime, if I give you 15, but that is also good. I ask you, give me two natural integers so that the product is 15. So in number theory, you shouldn't think in that way, that I have to find the exact answer by some method. As soon as you can limit the number of trials and errors to a finite number, you succeeded to solve the problem. So before doing something like this, there are potentially infinitely many choices. Okay? But if you can narrow it down to finitely many choices, even if that finitely many is 1000, at least you can help a computer. But if you have infinitely many choices in front of you, even supercomputer is not enough. Okay, so that is the idea. The problems in Math 4, you solve it decisively and get the answer. But here, no, you might narrow it down to a few number of options. By few, I mean finite. And then you try to see by trial and error which one will work. Okay, but that idea was correct. Okay, now let me tell you, I give you another probably hint. So let me just give you one hint, because it needs a little bit of experience. I would write it 5. So let me move these to the other side. So 0 is xy minus 5x minus 5y. Okay? But now I tell you the hint. Add 25 to both of them. So what happens, it becomes 25 is equal to 25 plus xy minus 5x minus 5y. Yes? And I think you can manage to do something. You should have some ideas. You might not knew about adding 25, but let me give you this as a hint. So what I'm telling you, This step was natural. This needs a little bit of experience why I'm moving to the other. This needs more experience. But then after that, I think you should be able to solve it by seeing this. Can I change this to something that I described here? Do you remember I told you that if A times B is 25, I can say something about A and B. Yes? But this is not a product, so I need to do a factorization. So this is now involved with Mat2C. So you see that is a good problem. Can you factorize it? Can you write this as a product of two terms? Yes or no? Yes or no? Even you can guess. Guess two polynomials that you multiply, it becomes this. It is not hard at all. It is 5 minus x times 5 minus y. Do you agree? So let us check. 5 times 5 is 25. 5 times minus y is minus 5y. Minus x times 5 is this. And minus x times minus y is this. And then it is equal to 25. Yes? And then we are solved. Yeah? We actually solved the problem because I am supposed to have x and y natural numbers. Let us work with integers for the time being. So this is an integer. This is also an integer. But I know that the product of two integers is supposed to be 25. But that there are no many options left. Yes, there are not many options left. I want to have the product of two numbers give me 25. So what are all possible options? So either I have 1 and 25, either I have minus 1 and minus 25, or what? 5, 5, or minus 5, minus 5. So I was able to narrow it down from infinitely many possibilities to only 4 possibilities. And then I can do and check them. For example, if you say this, there are two options. By the way, there is no difference between x and y. If an answer is x something, y something, you can also interchange because this is not changed if I change the role of x and y. So for example, here I would say 5 minus x is 1. 5 minus y is 25. Okay? Or, let me just solve this one. Does this give you an acceptable solution?
Yes.
It gives you x equals to 4. And this gives you what? Y equals to negative 20. Yes? But this is not an acceptable one. If I ask you find all integers, yes, this is acceptable. Okay, so this is not working. But let me go to the other scenario. So 5 minus x is minus 1. And then what is the other one? 5 minus y is minus 25. So this, do you think this will work? X becomes 6. This becomes how much? 30. So that is one pair. But immediately there is another pair. Can you tell me which is that? Because x and y are in. If I change the role of x and y, nothing will change. So another solution is x30 and y6. Yes? So that is also another pair of numbers. And these numbers probably was not that easy to guess. Okay, and the other scenario is this one and that one. So let us double check this. Okay, so what can I do here? I would write 5 minus x is equal to 5. And then the other one is what? 5 minus y is also equal to 5, which gives me x equals to y equals to 0. Not acceptable, because x and y cannot be in the denominator, because if they are 0. So this is not acceptable. And then other choice is that 5 minus x is negative 5, 5 minus y is negative 5. Then you are right. X becomes what? 10. Here, y also becomes 10. And that is also acceptable. Yes? But I want you to understand, by confidence now you say that there are no other options. Yes? So this we were able to find by that educated guess you told me, by looking at if x and y can be equal. But we couldn't guess these pairs. So in total, how many solutions are there? 3. One solution, the other solution, and the third solution. So it means that these are the only numbers that satisfy this equation. Yes? I will write one for you, but I don't want to spend time on it, so I want you to think about this for yourself later. But this is more challenging. The same type of problem, but you need to find appropriate numbers. If you like, you can think about it and we can discuss about it later. So solve this equation. 3 times x times y minus 5x equals to 13 in z. What do I mean? I mean that find all integers x and y that satisfies this equation. Yes? Here, I don't know. I just wanted to, because there is no specific way that I can teach you how to understand. No, are you criticizing what I did, or you are understanding how? No, I cannot explain that exactly. There is no, I mean, so what? I just added 25 because I saw that after adding 25 I can factorize it. That's it. That's the only thing, yes? Yeah. Yeah, something like that. But now let us go back to another problem. Go to another problem. But I think this one you can solve by the experience that you have. Even though this can be considered very above the level of the book, but I think you can still solve that. Okay, so if x minus a, y minus b, and z minus c are all divisible by n, show that x, y, z minus a, b, c is also divisible by n. Okay, so don't worry about the special cases. So x, y, z, a, b, c are all integers, and you don't have divisibility by 0. So assume that everything you want is there, you just prove it. You know that x minus a, y minus b, and z minus c, all of them are individually divisible by n, and then you want to say that definitely this combination should also be divisible by n. Yes? I want to wait a little bit for you. Okay, any ideas how to do it? Anyone could solve the problem? Yeah. I think you will be able to solve it. You can just tell me how. For example, x minus a is divisible by n. In the new notation we learned this year, we can write like this, yes? And then it means what? It means there exists, let me write q1. So let me write q in z, so that x minus a is n times q. We have the same thing, n divides y minus b, so this means there exists, you remember I have to change my letter in z, so that y minus b is nq prime. And then n divides z minus b. This implies that there exists another q, so let me call q double prime in z, so that z minus c is nq double prime. So I think everyone can write this, hopefully. But then your target is this guy. So somehow you have to make this coming out from your equations, from your equalities that you have. Yes, what do you think we will do? Yes? Yes, one way that comes to mind is to multiplying them. But then if you just want to multiply like that, probably it becomes a mess. And one rule of thumb in mathematics is to be lazy a little bit. Because if you want to do everything by brute force, then you will lose the insight. Yes, that is probably a good way of doing this, because you might say that, okay, I multiply this. And then if you multiply them, you have to multiply them as well. It becomes n to the power of 3q, q prime, q double prime. But by the experience you got so far, n to the power of 3 is not a problem. Yes? Because n to the power of 3 can be visualized as n times n squared q, q prime, q double prime. And then I can call this a q. So I have, that's good. It's not a big problem. And then something is interesting coming in. You have x, y, z that you want at the end. You will also have minus a, b, c that you want. So it's good. So if you want, we can follow this. Okay? So let me just follow yours, because that is your idea. Let us see if it works. Because your guess is actually an educated guess, a reasonable one. So hopefully it will work. But you have to be a little bit patient to multiply them, yes? So then I multiplied these two. So this becomes xy minus xb, and then minus ay plus ab, multiplied by z minus c. I have to multiply one more time. So it is xyz. Good, I need it. This times that is minus cxy. This multiplied by that minus xzb. This multiplied by that plus xbc minus ayz plus acy plus abz minus abc. So that's not big. I need only 8 terms. It's not. But the good point is that it's close, yes, because you have this and that, but you unfortunately have a lot of mess that you don't need them. So they are garbage, we just move them to the other side. That's how I think. I don't know if it is working or not, because I am following your idea. Okay, so minus ABC. I move the other parts to the other. So this is, if you want to, I can write n3q, q prime, q double prime. So I keep these two, which I need. The leftovers I move to the other side with the hope that I can get a factor of n out. Yes? And then, so this becomes n to the 3, q, q prime, q double prime. And then you move this to the other side, plus cxy plus xzb minus xbc plus ayz minus, I made a mistake here. What was that? It is abz, sorry, abz. So then and then minus acy minus abc. So that is what, and then now your responsibility to tell me how to continue. Because this is so nice, I think it will work. We have to give a little bit more energy to it, yes? Yes? Do you want to say something?
Couldn't you rewrite q prime, q double prime as a big Q?
Yes, yeah, I can do that, but don't worry about that. At the end, I will call something big Q. Yes? Okay. So what do I need to do? Do you see how can I work from now on? Yes, it is working. Can you see that? Because Yeah, so let me take cxy. Let me take this one with that one. And let me take xzb, which one can you say? With this one. And let me take this one with that one. Okay? So you will see why it works. So this becomes n to the 3 q, q prime, q double prime. Between these two, I can factor a c and a y out. So this becomes plus cy. From here, x is left. From here, minus a is left. Yes? And that is promising, because x minus a has my n in it. So I am happy now. This is the third time, yes, in a short time that I become happy. So then I go here, and then I take these two. Can you tell me what to do? Yes, what can I take out? A z is in common. So I have to, no, okay, sorry, I am taking the wrong one. This one with this one. X and b are in common. So I take xb out. Yes, and then z minus c is left. Good, because z minus c also contains an n. And then what can I write? I will take these two, a and z, y minus b. Yes, so it works. Yes, so that's very good, thank you. So this one is nq. This one is nq double prime. This one is nq. N, 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 n. So I can factor an n out, and then that would be a big garbage here. I can call it q. But of course, I have to make sure that this belongs to z, and I am, yes? Because if I take n out, n squared q, q prime, q double prime is an integer. This one is an integer, q is an integer, this one integer, so that's an integer. So this solved. Yeah, problem solved, yes. So it was reasonable. Understandable? So you see, it was quite an advanced problem. But if you get some experience, you can do better things. But is there any better way to do it? Yes? No, between you and me, you can talk. But if you want to write in the exam, if you don't write, I will deduct some points, yes? So when you write, you shouldn't be lazy. You have to write it down. But is there any better way to do it or not? So I will tell you the hint, but I will have time to solve it. What I'm saying is that instead of multiplying in this way, I will move a to the other side and then multiply. So y becomes what? And then there is, I told you, you have to be lazy a little bit. Okay? And then you start multiplying these, so x, y, z. On the right hand side, you see that a, b, and c at the end will be multiplied, but then everything else has some factor of n. You even don't need to multiply, yes? Because if you want to have nothing, if you just multiply these things, I agree, there are no n's. But except these three, it doesn't matter which one you choose, you have at least a factor of n. So it is clear that it becomes n times q, and then you move it to the other side, yes? Yes? Is that clear? So I mean that if you don't like it, still you have to multiply them. But this factorization is not needed. Because here in this factorization, you factorize to understand another, to get another factor of n. But if you multiply these three, always you see n in front of your eyes. You don't need to be creative after that. In your solution, you also have to be a little bit creative after that to understand how to deal with this mess. But in this method, n is transparent. You see it in front of your eyes. So I would say that might be this is a little bit better solution, but that's completely okay. Any questions? Yes? Multiply them. nq. No, so let me just write it. nq prime plus b, nq double prime plus c. So let me multiply. So it becomes n squared qq prime plus nqb plus nq prime a and then plus AB, yes? I do another multiplication. So from here, I don't need to be worried because this is a multiple of n. When I multiply here and there, it becomes a multiple of n. And then this one times that one is also a multiple of n. So at the end, I have a multiple of n, but the only thing doesn't have multiple of n is not a multiple of n is ABC. No, in the exam you have to write it down. I am just talking all these things, okay? Yeah, yeah. No, if it is in the exam, you have to write the garbage. Yes, yeah, yes. Okay, thank you very much and have a nice weekend. Again, the book is in the library. If you don't have it, please go and get it.